In this video, let us look at what an inverse function is. So if f is a function defined from a to b, so you have a set A, you have a set B. If f is a function defined from set A to B, and the definition of the function, let it be y is equal to some sort of function of x. That is, this function connects an element x in A to an element y in B. So y is the image of x with respect to this function. So if f is a function from A to B which connects x to y, then f inverse is a function defined from B to A. F inverse is a function defined from B to A such that f inverse of y is equal to x. The image of the element y with respect to f inverse is going back to x. So if y is equal to f of x, then x will be equal to f inverse of y. This is the basic definition of the inverse function. And the important thing to observe here is inverse of a function exists if and only if the function f is a bijective function. So inverse exists only for bijective functions, because here if x is related to, if you have x1 and x2 both related to y, if f is not a 1-1 function, if there are two different elements which are related to only one element here, then if you go to the inverse function, y will be mapped back both to x1 and x2. That is, with respect to the inverse function, an element y has two images, which makes it non-functional. And f should also be an onto function. That is, if you have an element y1 which is not related to any element in the set x, so when you go to the reverse function, there will be an element in the domain of f inverse which is not related to any element in the codomain. Hence, that will not be a function. So if f inverse has to be a function, f has to be a bijective function. So every bijective function has an inverse, and only bijective functions have inverses. And there is another definition for inverse function. So if f is a function defined from A to B and g is a function defined back from B to A, f comma g are inverses of one another. If FOG of x is equal to x and GOF of x is also equal to x. That is, if the composite function of f and g is an identity function, both in the forward direction as well as the backward direction. FOG as well as GOF are identity functions, then f and g are inverses of one another. So we know that the domain of FOG, so if you take FOG, g is first and f is next. So the domain of FOG is the domain of the domain of g, that is B. So FOG of x has to be an identity function on the domain B, and GOF of x has to be an identity function on the domain A. So if this condition is valid, then f and g can be thought of as inverse functions of one another. So this is also a mathematical definition for inverse functions. Now, what are the other things that you need to remember about inverse functions? So the inverse of a function is unique. There cannot be two different inverses for a single function. So if you take a bijective function, the inverse of the function is a unique function. Because you have only one inverse corresponding to a function. Next, the inverse of a composite function, FOG whole inverse is equal to G inverse of F inverse. FOG whole inverse is G inverse of F inverse, and GOF whole inverse is equal to F inverse of G inverse. That is, reversal law works with respect to inverse of a composite function. So inverse of a function is unique, and reversal law works with respect to the inverse of the composite functions. Next, the reversal law works even if you have more than two functions. That is, if you have FOGOH whole inverse, this can be written as a H inverse OG inverse OF inverse. So if you have n number of functions in the composition, and if you want to inverse it, just need to use the reversal law. FOGOH inverse is equal to H inverse OG inverse OF inverse. Next, the range of f, the range of the function f is exactly same as the domain of F inverse. So this gives you one of the standard process to find the range of a function. So if you want to find the range of a function, you just need to find the inverse function and find the domain of the function. Next, the graphs of the inverse functions are mirror images about the line y is equal to x. The graphs of f of x and g of x are mirror images about the line y is equal to x if f comma g are inverses of one another. If f and g are inverses of one another. That is, if you have a function f of x, so if you take this line as y is equal to x. For example, if you take this as the graph of y is equal to f of x, and let g of x be the inverse function. So if you draw the graph of y is equal to g of x, you get the exact mirror image of this about the line y is equal to x. So we have a graph which looks like this. It says y is equal to f inverse of x. The graph of y is equal to f of x and y is equal to f inverse of x are mirror images about the line y is equal to x. Next, if you are given a function, how do you find the inverse of the function? For example, if you have a function y is equal to e power x. So you have a function of the form y is equal to f of x. So we know that this function is a bijective function. This is an exponential function. So this function is defined on the set of real numbers to the set open 0 to infinity. So within this domain and within this codomain, y is equal to e power x is a bijective function. Now we are asked to find what the inverse of this function is. So what is the theory? if y is equal to f of x, then x is nothing but f inverse of y. So this is the theory which we use to find the inverses. Now, according to this question, y is equal to e power x. So if you can find what x is, that is nothing but the function f inverse of y. So if you apply log on both sides, ln y is equal to ln e power x, which is equal to x. This implies x is equal to ln y. So from y is equal to something, we have converted to x is equal to something in terms of y. So this is nothing but f inverse of y. And so f inverse of y is ln y. So what is f inverse of x? So if you want f inverse of x finally, you just need to substitute y with x. That is ln x. So as you can see, the exponential function and logarithmic functions are inverses of one another. And you can also see that this f inverse is a function defined from open 0 to infinity. Log is defined on open 0 to infinity to the set of real numbers. So you can see that the domain and codomain, the domain and range have interchanged, and the function have changed from exponential to logarithmic function. So this is the standard process to find the inverse function. So if you are given y is equal to f of x, inverse function can be found out by finding x is equal to f inverse of y. So if you take another example, very simple example. So y is equal to x plus 1 by x minus 1. If you are asked to find the inverse of this function, so you just need to convert this into x is equal to something. So what I do is I'll do the cross multiplication. Xy minus y is equal to x plus 1. This implies x times y minus 1 is equal to y plus 1. This implies x is equal to y plus 1 by y minus 1. Y plus 1 by y minus 1. This is nothing but f inverse of y. So this implies f inverse of x is equal to x plus 1 by x minus 1. As you can see, sometimes the same function can be the inverse of itself. The function y is equal to x plus 1 by x minus 1 is the inverse of itself. The inverse function is also x plus 1 by x minus 1. So I hope you understand the simple process by which we can invert the functions. So let us look at more examples when we deal with questions. So right now, you need to understand that y is equal to f of x implies x is equal to f inverse of y. And once you got f inverse of y, if you substitute y with x, you get the inverse function f inverse of x. The next point to understand is that the graphs of y is equal to f of x and y is equal to f inverse of x usually meet on the line y is equal to x. Usually meet on line y is equal to x. I say usually. That means there are some exceptions for this statement. So the graphs of y is equal to f of x and f inverse of x meet on the line y is equal to x. For example, if this is the line y is equal to x. So you have, assume that you have a curve y is equal to f of x which looks like this. So this is the curve y is equal to f of x. So what is the curve y is equal to f inverse of x? We have already seen that the graphs of f of x and f inverse of x are mirror images about the line y is equal to x. So if you look at graph of f inverse of x, it looks something like this. It has to look something like this. has to look something like this. And can you see that the points of intersection of y is equal to f of x and y is equal to f inverse of x usually lies on line y is equal to x. There are some exceptions. Like if you have the previous function y is equal to x plus 1 by x minus 1. So the inverse of this function is exactly same as the same function. That means these two are overlapping each other. That means you have the same graph for the function as well as the inverse function. So you have a lot of infinite number of points of intersection. All of them will not lie on the line y is equal to x. All of them will not lie on the line y is equal to x. And if you take another example, y is equal to 1 by x. So this becomes x is equal to 1 by y, which is equal to f inverse of y. This implies f inverse of x is equal to 1 by x. So you got the same function as the inverse function. We know that y is equal to 1 by x looks like this. So the inverse function is also the same function. So the inverse function also has the same graph. So all the points of intersection does not lie on y is equal to x. So you need to be careful about this statement. The graphs of the function and its inverse function usually meet on y is equal to x, but not always. There are some exceptions where the function is exactly same as the inverse function. Next. The next point that you need to remember is about the differentiation. If f and g are inverses of one another, if f and g are inverses of one another, we have already seen that fog of x is equal to x. So if you differentiate this on both sides, f dash of g of x times g dash of x by chain rule is equal to 1. This implies g dash of x is equal to 1 by f dash of g of x. So g dash of x, the differentiation of the inverse function, is equal to 1 by f dash of g of x. That is the differentiation of the original function at the functional value g of x. This will be a very useful function, useful derivation when we deal with differentiations of inverse functions. We'll look at it more closely in the chapter of differentiation, applications of derivatives. So g dash of x is equal to 1 by f dash of g of x. Whenever you see a question which involves differentiation of inverse functions, you need to use this statement. G dash of x is equal to 1 by f dash of g of x. So these are the different properties which you need to know about inverse functions. For now, the most important thing that you need to understand is how to find inverse functions. Thank you.